Hello everyone, I'm Surya Golagani, Director Marketing here at Datagaps, and thank you for joining us today. Before we get started, we have a couple of quick housekeeping comments. First, we have muted all mics to avoid unintended distractions. Next, the chat room is open so that you can interact with us through the chat. And finally, at the end of the session, we will open it up for Q&A for any of your questions to be answered. Today, in this webinar, we will explore how DataOps Suite helps automate your Snowflake data migration testing. On the panel today, we have David Small, VP of Sales and Marketing at Datagaps, and Shubhanshu Dikshit, Product Manager at Datagaps. And here is our agenda for today. We'll have a quick overview of Datagaps. Next, we will discuss how DataOps Suite helps automate Snowflake data migration testing. Then we move into its demo where we talk about different migration validations along with some BI validations as well, followed by a Q&A session. And now I hand this over to Dave.
Thank you, Celia. Appreciate that. And welcome. Appreciate everybody's interest in Datagaps. Today, really talking about cloud data migration and some of the pitfalls, some of the areas that we can help. It's a big market, and like to get started with just a couple of reasons why people move to the cloud. And you can find a variety of reasons out there, but sort of boil down into these three categories is certainly the need for better business agility to be able to compete more effectively, to meet your challenges more effectively. And that's one of the key reasons why people and applications move to the cloud. There's another reason which surprised me just a little bit, and that is the geographical distribution. In some countries, you can't store data about citizens and employees outside the boundaries of that particular country due to data privacy and GDPR and a variety of other reasons. So being able to move to the cloud and store data in that country, in that cloud environment, helps with that geographical distribution. And then probably the biggest driver and scalability. Again, the ability to scale out and scale back when you're trying to do the requirements for your application and improve performance and so on is a big driver as to why to move to the cloud. The global cloud computing market is absolutely huge. It's $483 billion in 2022 and is growing at a 14.1 compounded rate through 2030. What we'll be talking about today is really a subset of that market, and that is the data migration market. And that market is valued at $8.2 billion and is expected to grow to $33 billion by 2030. So data migration is defined, that is the process of selecting, preparing, and extracting, and so on. But it requires some things that Datagaps provides and is excellent at. Data profiling, the ability to make sure that the data is formed properly. Understanding the data quality of the data that's being moved and the data that's being ingested into the enterprise. And the ability to do ETL validations, data comparisons between what was in the old system that you've moved now to the cloud system, the ability to ensure everything's been moved properly and so on. So that's where we play in this marketplace. There's a number of reasons that data migration projects fail, and you can get all kinds of these off the internet. But one has to do with compromised data integrity, and that has to do with field content. So as you move data throughout the enterprise or move data from your legacy systems to your cloud environment, there's the content may not be the same. You may combine information in the cloud. You may separate information out, and there's really a critical step in planning that, and that is the mapping of the data from the old environment to the new environment. Certainly data quality is an issue, and data quality is really talking about your legacy environment and you're moving data from that legacy environment to the new environment, and if you're not paying attention to the data quality, then what you're doing is you're simply moving the data quality issues from your legacy environment to your new cloud environment, and you're not really addressing any of those data quality issues unless you plan that out. Another one is inadequate testing. Oftentimes, testing is really thought of as an afterthought, or partial testing is what people think about. So you test 10% of the data that's been moved, and we believe that you should be able to test 100% and validate 100% of the data that's being moved, along with testing your data analytics platform, and we'll get into that a little bit more in detail. Number 6 is data incompatibility and integration issues, somewhat similar to number 2, but it has to do with the data formats of the data that you're being moved. So if you're moving from SQL Server to Snowflake, for instance, the formats don't map one for one, and you have to take that into consideration. And so data incompatibility is an area that we help you with. And then finally, I added number 8, and that is failure to test the data analytics platform. It's absolutely critical that as you move to that cloud platform, that you test along the way the data pipeline, the data movement, but also you want to validate that the data analytics platform is performing, producing the same type of results. And we see that as another reason why cloud migration or data migration projects fail. So what we're all about at Datagaps is really focusing on and observing the data pipeline from the point of ingestion into the environment, into your organization, through your ETL processes to ensure that you're getting the expected results, but also validating the data analytics platform, so that point of consumption, so that you can make decisions based upon trusted data. And that's what we're all about at Datagaps. Now, our suite of products is illustrated here. So we have DataOps Suite, is an Apache Spark-based web implementation of our ETL validation, our data quality monitoring. We actually create synthetic test data, and that's a big part of the suite that you would use in data migration testing as you move from a legacy data warehouse application to a new cloud environment, as an example. We also have another technology, BI Validator, that really helps you with the validation of the data analytics platform to make sure that the regression tests are performed, that performance and stress testing, and that what you used to have in your legacy application is now the same as in your cloud implementation. So what a cloud, in this case, data warehouse migration might look like is you have your legacy on top and your new cloud environment on the bottom. You know, you've ingested data into, well, you will ingest data into both those platforms for a period of time, ultimately cutting off the legacy application and continuing on with the cloud application. But where we play here is data needs to be moved from the legacy application to the new cloud environment, in Snowflake in this particular example. And so, you know, you move hundreds, if not thousands, of tables into that new cloud environment. And what you'd like to be able to do is test to make sure that the formatting's done properly, the mapping's done properly, but also that the data has been moved completely. There hasn't been any missing data and so on. So we actually create a process where you take the 1,000 or so tables that are in your legacy application, and you point a wizard at those, and you point the same wizard at the migrated tables in the Snowflake environment, and it generates test cases for you automatically to compare the tables from the old and the new and give you any kind of discrepancies, any kind of deltas. So, you know, if you end up with duplicates, if you end up with null values, if you end up with fields that don't align, we provide you with a mechanism to very quickly and very easily find those things. Another area that we play is the ETL processes that fed the legacy application. Oftentimes, those same processes feed the cloud data warehouse, or it may be a new ETL process that feeds the new cloud environment. And you want to make sure that you're producing the same results that you were from the legacy to the cloud environment, or at least be able to test and see the differences and the expected differences. So we provide a mechanism to be able to take the output from the ETL process from the legacy applications and the ETL process from the new applications, and verify that the data is being moved and transformed properly. And we do a comparison and again give you the deltas between what was happening in the old and what's happening now in the new. And then finally, with the data analytics platform, oftentimes you would use the same data analytics platform that you used against the old environment, and you'd use that same data analytics platform to do reporting and dashboards against the cloud environment. And you want to make sure that there hasn't been any regression between the old and the new, that you can do stress testing and report testing, and you can do report to report validation, so you can ensure that the reports and dashboards that you were producing in the legacy application, now you're producing the same reports against the new cloud data warehouse. Or if they're a little bit different, we'll point out the deltas between that at a data level or at the graphical level by doing a pixel-to-pixel comparison. So those are some high-level areas that we help in the data migration projects. And the benefit is that we believe you should test 100% of the data. If you test a certain portion, then you're going to miss some things. The ability to have repeatability. So in the case of the wizards, you point to the old and the new, and it generates all of your test cases for you. So that's a repeatable process. Cost reduction. Over manual testing, we see in our clients report that there's probably 50, 60, 70% improvement from manual testing to automated testing. And then finally, what all that translates to is a reduced time to market. The ability for you to take advantage of the reason that you're moving to the cloud much quicker. If you can shave months off of that overall migration process, not only do you save time, but you save money, but you reap the rewards of moving to that cloud environment. So with that, I thank you for your attention. And what I'd like to do is turn this over to Shubhanshu to start the demonstration.
All right, can you guys hear me?
Yes.
All right, can you guys see the screen as well?
Yes, we can.
All right, okay, let's get started. So welcome to the technical part of the demo, where we're going to showcase the different ways we can create these test cases and how we can actually illustrate the changes and other differences and issues that we can catch during migration. Before we actually showcase the different products and the different use cases, I do want to give a quick rundown of how this rest of the demo is going to go ahead. Firstly, I would like to talk about the architecture of the product, how exactly the deployment and other aspects happen. This is to ensure and to make everyone else understand where the data sets and other aspects are being stored, given that compliance and security aspects are pretty important in our line of work. After that, we'll get into the actual showcase of the demo, where we'll illustrate how we can do different sort of profile comparisons, metadata comparisons, full data comparisons, and then run the wizard that Dave has spoken about already. After that, we finally plan to showcase BI Validator, which covers the final aspect, and between we also want to showcase the ETL transform validation. So with that out of the way, let's get started with the basic architecture. Our architecture consists of three components. The first one is the server, an Apache Tomcat server that orchestrates all the services, be it notification, scheduling, data flows, pipelining, and other aspects. This is what we will interact with via the web browser, but you can also interact with the application via REST APIs and CLI commands. What this implies is that everything that I'm going to showcase, or every button that you see within the application and more, can be done using REST API commands as well as CLI commands. So everything can be automated and integrated inherently by the product. More on that later. The second aspect is the heart of the product, which is the engine. And our application comes with two specific engines. Again, these are built for specific use cases. An Apache Spark engine, as the name suggests, runs on a Spark session, which could be either on a standalone cluster, which could be on-prem, it could be on a cloud Databricks cluster, or Neo cluster, or a Kubernetes cluster. Whereas a database engine, again, could be on-prem, but it's based on a database itself. The main difference between the two is how exactly datasets are ingested, processed, and saved. As you might imagine, in a Spark session, all the datasets are converted into in-memory Spark data frames or tables, and all the functions and test cases that we perform on them are converted to this corresponding Spark functions itself. Now, once the session is done, all the in-memory tables are exhausted and deleted automatically. A database engine, on the other hand, works by creating in-memory tables instead of creating in-memory tables, temporary views basically, instead of creating in-memory tables as we do in Spark. And all the other functions of comparisons and transformations are run via the engine's APIs and the engine-specific languages itself. The main difference from a business use case on both of them would be between ETL versus ELT systems. Easy example here is Snowflake. So if you're trying to actually pull data sets from Snowflake, that inherently could be an expensive operation, given that certain data sets could have a higher cost of sheer act of pulling them would have a higher cost. So in this specific use case, a database engine would shine because it doesn't have to pull out any data sets. It's just going to create temporary views for all the temporary data sets it might need to work with, and then work and process the data sets, find all the anomalies, all the mismatches, and other results accordingly, and save them as temporary views before closing that particular session and being done with the database for others to use. This, of course, comes with a bit of performance pull and bag between Spark and the database engine. Spark engine obviously is more horizontally scalable, given that it works with multiple clusters and cores and processes. So it's more akin to an ETL system where you have multiple vendors, higher throughput, whereas a database engine is again an ELT system that works more in specific conditions where the data sets are limited to the databases or close to limited to the databases. So that's engine in a nutshell. And finally, we have the repository, which, and by default, it's a Postgres repository, but our application supports Git as well. And this is where a test cases, your credential managing services, and other aspects, and the sample records and everything else that the application works with is going to be saved. All three of these components are going to be installed directly onto your infrastructure. It can be on-prem, it can be cloud. And the main point that I want to make here is that all the components are going to be behind your firewalls. At no point is any data of any kind, be it even metadata or even logistics, going to come back to DataOps suite, or sorry, Datagaps as a company. All the data, all the information regarding test cases, the profile connections, the data sets, the processing, everything happens behind your firewalls, and thus compliance is being met at every turn, and there's no data leakage. So that is a kind of a full picture of the architecture. I'm just going to showcase one slide of the typical description on how cluster deployment works in from a Spark engine perspective, where what we're going to showcase is we have the end user at this point. We're going to access the application via the browser. Once again, you can access the application via REST APIs in a developer mode and create commands via CLI as well. For the sake of simplicity, we're going to go through a browser with a good UI on that. We are going to connect to a data flow service. The recommendation configuration is present right here, which is in turn going to either connect to a Livy session or through a Databricks session. It's correspondingly going to connect to a Spark session inherently, and all the application processing is going to happen within that engine. So that in a nutshell is the architecture. Now let's quickly minimize this, and let's quickly run our application. We can just make sure our Snowflake application is on. So there we go. Welcome to DataOps suite. What you see in front of you is the home page of the application within our web browser. We have a dashboard with the common tasks, a dashboard that also showcases the different test cases that have been run. This can be your test cases, it can be your pipelines or your DB flows as well, along with the log activities of your users or the entire team. The main aspect and the most important pointer in this window is the multi-tenant container system that we have. This is basically our usage, our solution for problem statements which involve isolation of data sets and users. Much more simplified point here would be to, if you want to kind of isolate developer mode and production as two, or pre-production as three distinct environments, you can do that using the containers. It can also be repurposed for project isolation, which is a pretty common sight in a lot of data set related projects, where you want to ensure that certain users have access to only specific data sets and not the others. So in this case, I have created one specific curated example for us. So let's get to the next part, which is sources. I've already created the sources that we're going to work with here. And just to give a brief summary of what the business statement that we're going to work with here. For all intents and purposes, for the example, our migration is from Microsoft SQL Server to Snowflake. Snowflake being the common point here. But Microsoft SQL Server here can be on-prem or can be a specific one. But just to showcase how this works, works with specific credentials that we've already put in, as well as the connection to a specific JDBC. We have a similar connection that's needed for Snowflake as well, as I was just going to showcase. And the application, as you might notice, comes with an internal password vault, but you have an external, if you have an external credential management service, the application easily integrates with that as well. So if you want to work with your own existing credential management service or a password vault, the application has support for that as well. So I've just showcased a couple of sources, but I do want to point out, and this is something that's going to be reoccurring in the future webinars as well, that this is just a tip of the iceberg when it comes to data migration. We have not limited our product to just Snowflake migration validation, but it works with a plethora of connections. It can be Amazon, it can be Databricks, it can be Azure, Postgres, Oracle, Teradata, or even other aspects including files, APIs, or even complex files such as XML, Parquet, and others. This particular webinar, we're going to be focused on Snowflake, but in the upcoming webinars, we're going to see how migration validation could work for a system such as Azure, or if you're working with something along Databricks, something along those lines. And of course, in the later ones, we all do want to cover complex file use cases as well. So going back to our current topic, which is Snowflake and Microsoft SQL Server migration validation, we have already created our data sources right here. A quick pointer on our work schema, as you might just have noticed, this work schema, if I can just bring back the architecture, is actually the engine that we are going to showcase. So I do want to showcase both the Spark engine and the database engine. So I'm going to showcase the database engine, and here I've defined my engine as the Snowflake work schema. In terms of credentials, it needs the exact same credential that we need for a JDBC connection. Here, an admin role is required, as we will be creating in-memory tables and creating the specific use cases. So with that, we wrap up the sources aspect. So far, we have just made sure we have created a container, logged in, and we have created connections and to our data sets. And now we want to define a basic migration. So let's start at the very beginning, and let's start with a database engine example. So you have a particular data set that's being migrated from SQL Server to Snowflake, and you'd like to ensure that you validate this. So of course, before you do a full-fledged validation, we highly recommend doing something called a profile validation. So what is a profile? Well, a profile in a very simple terms would be the different statistics and the profile of the data set itself. This includes things that I'm showcasing right now, which are everything from the data type to the count, the exact volume that you see, the minimum and maximum values within the data set, the averages, the minimum maximum lengths, the number of missing values, basically the null percentages, and the other aggregates such as sum and averages. So the way we actually do this is we first define a profile, and we see if the profiles are directly matching. So now that I've defined what a profile is, let's go back and see what's happening at a broader scale. My data flow, what you will say, has sources, processors, and data quality nodes. Starts with a basic pulling of profile from Snowflake. I go to properties, you'll see my data set here is my Snowflake data set, and my query is just a DIM customer pulling from a particular data set. My application comes with an inbuilt query builder as well as parameterizations and other aspects, and the columns are being filled in right here. Of course, I can choose which profile sets I want to define before the results are made right here. A similar thing is done for my data set from SQL Server. As you see, data set here is from SQL Server. Again, a query is being pulled in, and I can just drag and drop these tables as I will in a few minutes. And the columns showcase the corresponding profiling, and the results are right here. Finally, when we actually look at the actual run, let me just go to profile and show how this works. You first define the data sets you would like to compare. Now here, these are the profiles of the data sets that we are comparing. The mapping window automatically maps the corresponding data sets based on fuzzy logic. So if you have a couple of columns right here, address line 1 and address line _1, the application understands that and tries to match it accordingly. If there are complex changes, you can actually go in and change the corresponding column type yourself or upload a file as well. I'll showcase that in the data flow system. And finally, just to round this particular profile compare out, we see that the status here has failed. This doesn't imply that the component has failed. It implies that the test case has failed, implying that out of the 212 corresponding aggregates, we have found failures on multiple. It basically implies that there are specific cases where there's a difference between the source and target. A quick example here would be that we see that the distinct number of geography keys between our system are slightly different. And of course, you can actually get in and define what your thresholding could be for these specific data sets. And that is in your allowed variance. Since our allowed variance is 0, even a 0.01% of variance is being marked as a test case failure. So far what we have done is that we have picked up 2 data sets and we have tried to match their profile, and we see there's a failure. Well, that's pretty obvious that we might find some failures. And so let's dig deeper into it. Let's go to the next aspect. And for this, I'm going to move into data flows to illustrate the other aspects. So once again, we are in data flows, and this is our Spark engine. The application comes with both engines, and the only reason we're illustrating both is for different use cases, you might have to do either or, and that's why I would like to showcase both. So the very first thing that we would like to do is actually run a metadata compare. Because if you think about it, the sheer amount of metadata changes on an architectural level between SQL Server and Snowflake are inherently vast. And this is not just between SQL Server and Snowflake if you're transferring things from Oracle to Snowflake, or between Oracle and Databricks itself. There are inherent data type changes, and there's a need for inherent data type mapping present. Because in some data sets you might have, or some architectures, you might have precision decimals, and in others you just might have float. And that inherently is going to cause a difference between your data sets. So let's first ensure that we do a metadata compare. So how do we do that in the application? Well, I go to properties, I select the data sources that I showcased earlier, and I select the schema I would like to work with. Here my source and targets are right here. Of course, this can be interchanged as well. This is just one or the other. And then in objects, I just drag and drop the corresponding objects that I would like to work with. So let me just find another dimensional table for now. So here we have multiple dimensional tables. Let me try. I'll drag and drop dimension scenario. You'll see that div scenario has already been found in the target object as well. Again, our main aspect here is that we don't want our users to manually go in and do a lot of stuff. If something can be automated, we try our level best to automate it. So in this particular fashion, multiple tables can be selected at once and defined, and the corresponding target objects are usually found automatically. If not, a user can go in and try to find them specifically here as well. I've already run a lot of these flows in lieu of saving time. And with the result of this particular test case is also failure. We see that there's a failure between the metadata. And if I see that points out which exact aspects are failed, the first thing that I see is there are columns within my DIM customer which are not present in my source, implying that within Snowflake, these columns are absent, and within SQL Server, sorry, the other way around, that these columns are present. That implies that there are a few column mismatches are going to be present. There are column length mismatches. This is particularly important when you're working with string columns. An easy example here would be address. As you might imagine, some addresses could change, and inherent auto trimming might reduce or might limit the number of characters that a particular column might have. So your column length is actually pretty important in this case. And finally, the key important would be the data type mismatch as well. We see DIM customer is the problem child here because we see that it also has a corresponding data type mismatch. So that is metadata compare. Now let's get to the main crux. We want to ensure that the full data is being validated one against the other. I've prepared this already, and I'm going to showcase running this once again. And for this, we come to the actual test cases. Now, before we move on any further, I'd like to pause and just explain the other aspects that are present on the screen. Towards the right, we have a plethora of nodes. We have JDBC connections, we have files, APIs, and Power BI connections as well, the ones that we saw in sources earlier. Then we have a plethora of processors. And this could be SQL, this could be Python, this could be Scala, or it could be a custom plugin that you can define yourself as well. More on that later. And after that, let's skip data quality. We also have sync, which basically implies that you can save the results of your transformation as files or as views or as tables within your DB. And finally, we have BI analytics. This is again going into BI specific validation, which we'll skip for now. So if you notice this, you will see that it's very much akin to a full-fledged ETL tool, and that is because it is a full-fledged ETL tool. You cannot validate any ETL system without having an ETL tool as your backbone. So a good number of our clients actually use our application as a full-fledged ETL tool as well. What this also ensures is that if you have any kind of transformation that you'd like to validate, we can replicate those transformations as well, be it in Python, SQL, Scala. Of course, there are other languages that can be supported as well, like DB scripts. So that's the aspect of what we see with regards to the nodes. Of course, within data quality, we have multiple nodes, few of which we will discuss right now. The main gist I would like to point out here is that none of these are limited by one or the other. I can pull in a file, I can pull in a JDBC, and I can run a data compare against them. I can pull a file, an API, run them through different processors, and then run some comparisons or some data rules against them as well. There is no limitation on the creation of test case. You can create your own customized test case. You can always go back, parameterize it, and then export it as well. So you can import it multiple times and create a particular data set flow that you can deploy and multiple times. And that is actually what we're going to showcase as well, because that is an inherent product feature. With all that, let's get back to our original problem statement. We have transferred files from our SQL Server to our Snowflake, and we would like to ensure that these transfers actually valid. We already have seen that there's a few metadata mismatches. So let's see how the application deals with it. Firstly, I have SQL Server right here. SQL Server, I define my source as SQL Server. I go to query and I define my corresponding DIM customer right here. Again, I did this by just dragging and dropping this corresponding table, but I can also use Query Builder to define the same. In the results window, I can see a typical sample, the schemas of the particular rows, and also how many partitions and how many rows are loaded. The throughput is actually something that works really good if you have a high transfer JDBC connection as well. But again, that is dependent on your connection itself. In a similar vein, we pick up the same file except from Snowflake. Here we see, yes, Snowflake is present right here. And within the query, we see that the order of the columns is slightly different, but it's more or less the same. And we do know that there are a few columns missing. And so in the results, we see that, okay, there is a few records missing as well, but this doesn't give the whole picture. For the whole picture, we actually go to the data compare node. Data compare node is our base node for validating data sets. What this particular node does is that it takes the entire data set and compares it against the other. It checks for duplicates, it checks for missing records from one against the other, and it has a plethora of user-related options that you can define. These include automatic data type conversion, enabling trim, considering null and empty spaces the same. If duplicates exist, we do not want that test case to fail in other aspects, and also define the specific differences. And that's what you see right here. Additionally, there are thresholding options as well. This is particularly important when you're working with numerics and float values, where you might imagine because of some rounding, you are expecting some slight differences, and you don't want a test case to be mapped as failure because of those reasons. So the application has automatically mapped this particular set of columns for us, as you might see right here. All these columns have been automatically mapped, and here, based on the fuzzy logic itself, it's mapped. And as you can see, there is a few data type mismatch changes, and we have also defined our primary key as our customer key. This is important if we want to ensure that we can check some records one against the other. We need one column that can be defined, one or more columns that can be defined as the anchor or the joining key in SQL words, or against which we are going to see if there are any results mismatches. And finally, because we did know that the corresponding yearly income was a different data type, the application converts them both to long right here. And now let's look at the results. See, the results have already run this, and I see that, okay, there's about a 90% or a 99% match in Snowflake. This implies that most of the records that have been transferred into Snowflake are a full-fledged match. That's pretty good. And there's a few mismatches as well. If I go to mismatched, I can see the exact issues that I've seen within my data sets. And for a much closer look, I can actually go into column-wise mismatch and see the exact problem childs and exact places and columns which are causing specific problems within my data set. So here, if I would like to work with this, say I want to push these particular data sets back, I want to reconcile them. These are not just for show. These are complete data sets that I can pull and use again. So here I'll drag and drop SQL for now, and I'll drag and drop differences. And what basically this picks up is the difference data set that we have right here between our two distinct data sets. Of course, I can pick up the other aspects as well. And moving ahead, the place where we go a bit beyond, not just validating full data compare, we also check where records are absent. We see that there are records present only in dataset A, which is SQL Server. And this could have a lot of implications. And the most important implication here implies that there's been a problem within our transfer. Either new records have been flooded into the SQL Server, or the batch specific migration process that we were using has failed at some points, resulting in these set of records which are only present in SQL Server but are not present in Snowflake. And of course, if there are any duplicates and other aspects found on our primary key or keys, that would also have been counted right here. And depending on whether we wanted to fail our particular test results, the test case would have failed on that particular reason. So that is a test case of migration validation. Just to reiterate what have we done so far, we pull in specific data sets as in-memory tables, we run a full data compare, and we run a plethora of tests against those. And in case there are any specific failures, the corresponding user is immediately notified, and every run is being kept track of. Let me just showcase that real quick. You see every run is being kept track of, and here we see that this particular test case has failed because this particular component has failed. And I have the report right here that is automatically generated for me, which I can download or which I can send ahead as well. There are a lot of integration options as well. And if you want to say automatically raise a Jira ticket, which with this particular report stating that this particular migration has failed, the application has inbuilt plugins for those as well, which I'll get to shortly. But again, this is just one report. And of course, if you do not like this report, the application comes with customizable reports as well, which again, I'll showcase in a bit. Right now, what I really want to focus on is the wizard. Because of course, the first aspect that you might be thinking is, okay, I have about 500 tables that I would like to migrate and validate. I can't just make a test case for each of them. And that's something which we understand. And of course, you can create your own specific test cases and export them as well. But we have done one step further, and we have created a wizard. So what I'm going to do is I'm going to basically create migration validation as a folder right here. And within this folder, I'm going to go ahead and generate multiple test cases. So let me just give them a prefix of MV and put them within our migration validation folder. Now, for the sake of simplicity, I'm going to take Snowflake 2 and SQL Server. Again, source and target can be mismatched one or the other. And I automatically import all the tables from both the sources. Now, what I'm going to do here is I'm going to pick up a few dimensional tables right here. Pick them up right here. And then correspondingly, I'm also going to pick up a few fact tables. And other reason I'm showcasing this from this perspective is just to illustrate how easy it is and how easy it is for the end users to define the corresponding set. So I guess this is a good enough showcase on how differently you can add multiple views. And as you see, the target objects have been easily marked. I'm going to remove dim customer as we've already created that, but just to showcase how mapped and unmapped columns come up. We see that most of the columns come up as mapped automatically. But if I go to dim customer, I might see that there are a few unmapped. But here in this case, we do not see any unmapped columns right here. In fact, we see that about all the particular data sets have successfully mapped, and there are 0 data sets which have any unmaps within them. And this unmapped here would define that if there's a column present which the application could not map against another column. Of course, everything that is mapped is done using fuzzy logic. And if you would like to go in personally and change them, either you can go in right here and change it. You can select the specific one and change it, or you can give a file to the particular user that can help the application understand the mapping and change it accordingly. So far, we have created this set of mappings that the application has worked. And if there are no mappings created by the application, we can go in manually and do it as well. Of course, we can add specific columns right here as well. Moving on, the next aspect is with regards to options. Again, these are the same options that we have seen earlier. I'm just going to automatically compare in our case here as well, just to illustrate the example. And as soon as I click generate data, please right here, I see that there is a few data flows that have been already created. I believe the customer is the one that was already created. So if I can go back real quick, I'll just change the name of this right here. MV1, and there we go. Everything else can be done automatically. I can generate all data flows as is. And now within MV, I see that yes, there's a plethora of data flows that have been created. And in fact, it goes to the second page as well. And this can be exploded to about 100 data flows as well. And now the next question, in Lou is how exactly do we run this all together? Well, that is pretty straightforward. That's where pipelines come into picture. I already created one pipeline, but I'm going to showcase how this particular pipeline works. Let me just call it's pipe. So the way this particular data set is going to work is that within my left side, you see a plethora of task panel usages. Now, these are all the data flows, the DB flows, data quality monitoring, and other aspects that we have. Since we work with PI Validator and we also have a synthetic data generator, the different products can all work in tandem here. And since we have conditional clauses and other aspects as well, we can choose how the pipeline works overall. Just to reiterate, everything has the corresponding API as well. So if you want to define a pipeline right here and run it from externally, your own CI/CD tool or your own test plans, like Azure test plans or specific test plans, we have integrations for those as well, which are inbuilt. Now, going back to a very simple use case, we just want to ensure that this has the data flow that we want to work with. Let me pick up just metadata compare right here for the start, and I'll define that as my start. And now I would like to add multiple data flows from here. So here I'm just going to go to add data flows. This is going to open a pop-up which actually contains the data flows that we saw earlier. Let's go to MV itself. And well, let's just drag everything out here. And let's just we can choose if it's in parallel or sequence. And in the upcoming version, which is the next one, which I don't have, I'm working on one version below. We also have the ability to choose how many data flows we want to run in parallel. So here I'll just go for sequence for the ease of understanding. And what this basically is going to do is going to create the entire data set that's going to run one after the other. Each data flow is going to run. And correspondingly, we have multiple runs, and these runs are going to be tracked. For the sake of time, I've already done this thing previously, as you might imagine right here. I'm just going to go to a previous run. As you might imagine, a few of these might not be present here. Or yeah, let's just go to the previous run in our data flows itself. So here you can actually keep track of each of every data set that has been run specifically. And correspondingly, as I showcased earlier, each of every flow is being kept track of as well. So in the past, if you see specific runs, and if you want to keep track of how this works previously, you can keep track of that here itself. So that is migration validation with a wizard. Now, there are a few things that I have said that I will cover later, and I would like to quickly focus on that as well. Firstly, a quick shout out to plugins, given that it's very important for our integration systems to work with. And the way plugins work is that if you remember, we discussed we have Python support. Well, if you want to define Python support, but you want to make sure it has a single repository and it has parameters that the end user should not worry about on the code, and end user should only worry about the parameters, you can do that as well. So that's parameters, and it's a tip of the iceberg of what we're going to skip, so that we can move on to the other aspect, which is ETL validation. So for this, once again, I'm going to a different container where we have created a specific test case right here. And here, let's showcase how exactly ETL validation works. Now, there are two trains of thought for ETL validation. There's white box testing and black box testing. White box testing here implies that you as a QA tester are aware of the exact logic that the developer has created. And so you replicate that logic. You don't copy code, you replicate the logic independently and do it against the same source file and see if whether your transform data set matches with the original transform data set. And that's the story here. The story here is that we have this particular file, which is our dem customer once again, which had geography key updated. And since geography key has some functions updated to it, this is the final file, which is corresponding output. So I'm a QA tester. I pick up the source file. Again, this was from a different system. And then I first pick it up normally. And using my data transform here, I apply a basic custom function. This is the function that I have applied to basically showcase that, yes, even I have done the same transformation logic. And then I apply a data compare. And in this case, what I see in my data compare is a mismatch. Okay. Then column-wise mismatches, I see that only geography key is the mismatch column. And if I go into mismatch records, I see a pattern that it's 20 versus 18. Now, this could be that one of the keys, mapping keys in the production versus dev environment might be incorrect. This could be that the logic for 18 versus 20 might be mismatched. Or this could be that there's been a concern or a problem within the transformation. I can just pick up this specific data set, once again, make a SQL out here, and then send it back as a corresponding data set itself, either as a file or a view, or I can just connect it to Jira and set it that way as well. If I go back to run histories, I can actually see if there's a specific system right here. So of course, this test case has failed. And because this test case has failed, I can go here, I can create a Jira ticket manually, or apologies for that, I can create a Jira ticket manually, or I can automate this Jira ticket creation as well. So it goes through the entire level. So this is, of course, black box testing. And of course, you're not going to create transformations and validate that against each and every one of them. So there's a different method for this, which is white box testing. So here, again, the system lies quite the same. And a way a lot of our clients are using this is that they pick up their source file, And instead of using the data rule node right here, they actually perform their transformations right here, and they validate their transformations against a set of rules. So that's black box testing. Black box testing implies that you are not sure of the exact rules for transformation, but you are sure of the exact bounds and limits that the final data set has to follow. This could be that even after 6, 7 joins, the record still should be unique, or they should not have nulls in certain columns, or it could be along the lines that they should follow certain business rules. So let's take a quick look at these few. Here we see that the data sets have been pulled in. Again, this is a transform data set. And here, these are zero code or low code systems that again come with import and export functionality and parameterization inbuilt that any user can define. Creating a duplicate rule is as easy as 6 clicks or so, where you can just click on the duplicate check, define what corresponding column you would like to check duplicates against, and I'm done. The success criteria inherently implies that there are 0 duplicates, but if I want to allow a few duplicates, and I can define that, okay, I can allow less than 5, then it's successful. This is just one way, and this is the most simple way, but if you want to do something as, a little more complex would be null. Here, a null check is as simple as defining the column and then correspondingly choosing the list of operators right here. And speaking of this is actually called the attribute rule because it takes into account the data type you're working with here, and the operators are correspondingly changed that way. Easy example here is email address, because email address is a string, and my business requirement here is to ensure that my email address contains only adventureworks.com domain. I use the container operator. In a different use case, I want to ensure that within my demographic records, there are no birth dates before 2005. So I define that date right here. This can be parameterized as well. And because birth date is again a date column, the operators are is before, is after, is between, and such. The cherry on top here is that if you have some specific use cases, as we might see in pharmaceutical or healthcare systems or insurance use cases where you might have specific rules that you want to define, these operators can also be user defined. So all you have to do from an end user perspective is have the operator created by a developer, and all you have to do is define them once here, export the rule, and then deploy them once again using the wizard that we have on multiple rules all at once. So here we had a few check of rules. Apart from business rules, we also wanted to ensure that the first name and last name only have specific characters. They don't have numbers and other aspects within them. And the results are very akin to what we see in data compare, where we see all the pass-in, and whichever record is failing, that record can also be pulled out as a CSV right here, or you can pull them out as data sets and then work on them accordingly. So in this way, a few of our clients actually use the system of transformation to validate their logic specifically against rules and against existing data sets as well. A very easy example for the white box testing would be that if there's a change that's happening on in the production side, in the development side, and you'd like to ensure that this change does not affect subsequent data sets, all you have to do is run the corresponding ETL transform and then validate the rest of the data sets one against the other, and then we can actually ensure that because of one change in the process at L0 or L1, L3 views have not been affected in an unintended way. So it's quite a bit of information for the viewers to digest, but we still have one more section left, and which will take us just about 5 minutes, harkening back to the PPT that Dave was showcasing earlier. The final aspect is still left. We have validated the data, we have validated transformations, we need to validate the reports. And that's where BI Validator comes into picture. So this is actually a different product of ours. I won't get into the architecture, but it's a thick client version, which is again installed directly onto your Windows machine. It has server components as well, which can basically ensure that you can run on multiple Windows machine and one single person can have admin access, so as to ensure credentials and other keys are being managed from one location itself and not shared. But basically, this application connects to your Power BI or Tableau connections. Here, let me just close this again. We have a plethora of connections right here, be it Power BI and Tableau. Since those are the most popular ones, we'll be showcasing those. And they work with just a basic connection credentials, which are username, password, and so on. There's a lot of things that I'm going to be skipping over with regards to connections as well. Things such as the variants of the application type that you might come in. And of course, the same thing that can be applied for Tableau as well. The basic gist here is that if you'd like to ensure migration validation, I've already created the specific aspect right here. You can actually see it right here. So the business story here was quite simple. Before a particular migration was done, there was a data set and there was a corresponding report. That's our customer analysis. And after migration from Snowflake, there was another report created. So here we want to ensure that both reports are actually valid. This could be along multiple dimensions. But first and foremost, let's ensure that the data sets were valid. So here, first showing you the results, we see the pre-connection and the post-connection results, and everything that's highlighted is actually incorrect. We see there are lots of highlights, and we see that on first glance, the reports might look the same, but if you look deeper and you see that there are the highlights, we see that there's a lot of differences. There's a lot of data-related issues. There's a lot of report-related issues as well. So between our pre-connection and post-connection, just to reiterate them, between our SQL Server and Snowflake, we see the end results of our dataset migration, the BI side, is actually still not yet validated. We see a lot of mismatches here. And if I go back to see how exactly this works from a user perspective, all you need to do is define the connections that we saw earlier. This could be the connection to your original data set, original connection, original legacy system, and the post upgrade could be the new Snowflake system. Advanced options are there just to keep track of other aspects as well. Do you want to compare filters? Do you want to compare parameters? You want to compare slicers and everything else that comes in between? And correspondingly, the next thing to do is just select the report that you want to work with. You can just drag and drop multiple reports. And once again, similar to what we showcased earlier, it's just as easy as dragging and dropping, and you're done as an end user. The application handles the rest. In the same vein, if you're working with Power BI, again, just to showcase, we have same things for Power BI as well. It's pretty identical, given that the reports, if they are incorrect with regards to text, with regards to appearance, that is something that's being kept track of as well. But if you want to go ahead one step further and you want to keep track of connections, take, for example, the connections, the credentials of the connections, right? There are the user groups having a difference between them, between the original, the legacy system, as well as the final system. That can also be kept track of using catalog. So here, just to illustrate what this means in a very basic sense, something as simple as a visual position change of a particular visual, which can be a chart or it can be a text or any other aspect, even that is being kept track of. And as you see, these are just a few of the easily accessible components that the application keeps track of, but it goes again further to that as well. So if you're working with connections and connection to your Tableau report, if they have been altered or if they are changing from a specific system, that can also be kept track of. And of course, everything works with the bookmarking, a snapshot, a benchmarking system as well. So you can easily work with that application. Finally, we have a performance aspect as well. Of course, just because you're shifting from one to the other does not mean that your corresponding performance should be impacted heavily. So if you want to either run stress tests or if you want to run performance metrics and keep track of your reports throughout the migration validation process as well, we can do that as well, where we basically impersonate users or we try to keep track of performance metrics of reports through multiple runs. And everything can be scheduled right here, and everything can be accessed via, again, APIs and CI/CD tools as well, and again, test plans as well. So that as an overall system as basically where we come in and validate the system end-to-end and validate a migration system from an end-to-end perspective. Just to reiterate what we've done so far, I can just pull back and showcase. We've actually gone into this application, created our connections very easily. And the first thing that we have done is that we have actually defined in DB flows, we've actually gone and defined the profile comparisons. Actually checked if the profile of the data sets are matched. Then we see that there's a mismatch. Let's go one step further. Let's see metadata. Then we have checked if metadata is being matched or mismatched. We see there were mismatches, but let's do a full data compare. So the first thing that we did was created this particular flow and validated the entire data set and worked with the corresponding mismatch records and saw if there are records missing, duplicates, and other aspects. After that, we went through the wizard and saw how to make this particular test case, except in much more faster pace, and create them all at once. So here, this is just the same test case that we have seen. And if you want to create some more complexities, maybe add a SQL here, maybe add a plugin here, that can also be done using the wizard. All you have to do is define them right here, then export the data flow as is, and then you'll be good to go. Then you can create 100 or maybe even 500 test cases all at once. And if you want to run them, all you have to do is define a pipeline. Within the pipeline, all you have to do is define what are the data flows you would like to run at once, either in parallel or in sequence, and you're good to go. So that's what we've done. Let me open this particular pipeline as an illustration showcase. Yeah, this is how it might look. Finally, the few things that we couldn't get a lot of time to discuss were actually the plugins and the integration options. So if you're working with, say, Azure, or if you're working with other CI/CD tools, the application comes with inherent plugin systems. And if there is not an existing plugin system that's inherent to the product, you don't have to wait for a product cycle to get the feature you want. The plugin systems is very powerful, and it helps us give out features to our clients at any point at a moment's notice. All they have to do is define what they want to do, what are the parameters, and then either they themselves can go in and create specific parameters and the test cases, and they can handle the code themselves, or in many use cases, we can come in as expert services and create the plugin for them as well. So what this basically implies is that at no point will you be able to be waiting for a specific feature to come, because we tag ourselves as the most comprehensive data validation toolset out there, and we would like to stand for that. So yeah, a lot of things covered. This is definitely an information overflow. So before we actually end the technical aspect, I would like to see if there are any questions on that.
Yeah.
Surya,
Thanks,
Dave?
Shubhanshu. Yes, we do have a couple of questions coming in. So one of the attendees asks, once you have validated a metadata failure and defined that the difference is acceptable, can you mark this as such so these failures don't show for further validations?
All right. So in this case, if you want to ensure that this particular metadata is accepted, that okay, this is what we're going with, all you have to do is define that within the properties itself. And if you want to retrieve metadata for each node, if you like to define columns as such names. So now if certain columns was, take for example, DIM customer itself, here there was a data type mismatch and there were columns missing. So in the subsequent run, you don't want this corresponding issue to cause further failures. Well, there are multiple ways to achieve this. You can either remove the corresponding data set itself, or you can work with checkpoint system. So checkpoint basically creates a snapshot of the metadata that you're working with and doesn't recall it unless you ask for it. So yes, that can be achieved, although it's not directly within this can be showcased directly right now, but it can be achieved.
Right. Thank you. Another question, it says, I want to test the data migration from AWS to MS Azure. Assuming we have set up Datagaps in one cloud service, let's say Microsoft Azure, AWS is the source and MS Azure is the target. Are these scenarios supported by Datagaps?
Absolutely, that's a very good question, and because it harkens back to the original point that yes, this example is specific to Snowflake, and so we are running our system on Snowflake or a cluster, but it can work on anything. We are agnostic from a cloud and on-prem perspective. If you want to run us from on Azure system, if you want to run us on AWS, we can run anywhere. If you want to connect us to Azure, if you want to connect us to AWS, if you want to connect us to an on-prem file SFTP connection, everything is valid. So yes, we can do that, and we have multiple webinars planned where we actually go into, I believe Azure is one of the webinars that's upcoming as well, where we'll deep dive into that specific migration validation system as well.
Right. So the same audience again asks, if the data volume is too high, let's say between 2 and 4 TB, can this scenario still work?
Yes, the scenario perfectly works, because once again, the main gist here is that the Spark engine is horizontally scalable. So it all depends on the process and the amount of infrastructure cost that you're willing to put up with this particular aspect, because you're going to run an EMR cluster in many cases, or you're going to run a Databricks cluster, or if you want to save, we also support Kubernetes. So you're going to run any of these. And so Kubernetes in most cases supports auto scaling. And so if you're working with different sort of volumes, the application scales up accordingly. And the main aspect here is that from our side, there are no limitations. In fact, we do a lot of performance case studies as well. I think one of them is just right here, this is a performance case study when we did about 1 billion. And this is just a smaller one, but we have worked upwards of, I believe, 20 TBs as well. So we have gone to a really high scale as well. And the application has not seen anything from its end.
Great, thank you. Another question, is SAS supported for report comparison?
I believe so, yes.
Okay. Another question from one of the audience. Will the tool support XML data validation?
Oh, yes,
Or
that's
table
actually,
to file validation as well?
yeah, that is actually one of our famous use cases that we have. So here you have an XML file, and I know exactly what you might be talking about. You have this object files, arrays of structures of arrays, where it's very difficult to pull this data out and work with it. Well, we have an inbuilt library or a plugin that converts those complex objects into relational data sets, as you see right here, while maintaining the relations, and then correspondingly you can work with them. And here that's what we have done, basically pulled out those specific data sets from the complex file and run a data compare against them right here. So yes, we definitely support XML. In fact, we have libraries really good for that.
Yeah, and any limitations of the data volume there? I don't think so.
Not to our knowledge. We have done very huge benchmarks as well. So I mean, if there are some specifics, if there's some really high use cases, feel free to connect to us directly. We're more than happy to have a discussion on that, because with high data volumes, we also need to ensure that it has the performance needs to be validated against cluster performance. So if you have like say 100 TBs, you need to ensure that the engine that's running that is also capable of handling that much volume. Again, that too against two data sets of 100 TBs. So we definitely have never seen a problem from our end on that from the software perspective, but of course hardware sometimes can give out some specific issues with regards to driver memory.
Okay. So another question here, like, will the tool store the test data in cache?
Temporarily. So just to illustrate, so what you see right now, take for example this matched set of records. This is actually stored in the repository. This particular sample records are being stored in the repository, which once again is behind your infrastructure. And if something is running, take for example, I run this data flow right now. Since this is running on a cluster, everything here will be an in-memory table. And as soon as the session dies, all this data is wiped out as well. So technically nothing is stored in cache as such, because it's going to be in memory in temporary views, or it's going to be in the repository. Nothing is going to be stored anywhere outside your system mainly.
Okay. Another question from the audience. Do you have Vertica connectors?
Vertica is a CRM tool, I believe. So we should be able to work with that connection, although I don't think we have it right here. But once again, since we have REST API connections and generic connections, we should be able to connect to Vertica as well. I mean, even if it's a streaming data set, we already have streaming data sources connections as well. So I'll have to get back to you on that one. But yes, I believe we can connect to Vertica as well.
Okay, great. Thank you. Thank you so much for answering
We
these.
did miss one question. I do want to address that. So I think it was between file and table. Yes, we support table to file validation as well. Just to go back in data flows, if you're working with a corresponding, say, file and you want to check it against a corresponding JDBC connection, once again, here data compare, as you see, one is code, one is file, one is an API, one is a file. Anything can be supported. There's no limitation from our end.
Great. Thanks for that, Shumanshu. Dave, anything in specific that you want to share that we usually hear from our customers or clients?
No, I think, those were good questions. Let me validate the question about is data analytics product SAS supported, and the answer is not yet. And, so that's something we'd be happy to talk about. We get a lot of questions regarding the performance and that. And our clients report back to us that, we perform very, very well, again, because the underlying architecture is Apache Spark. And we think by moving the BI Validator into the DataOps suite, it just opens up a wide variety of additional testing capabilities. So, we've got a lot of that done already, and we're continuing to enhance and move things and create that one DataOps suite technology product. I would like to thank everybody for their attention today and attending the webinar.
Yeah, Dave, we have a couple of more questions from the audience.
Oh, okay.
Yeah.
Okay.
So can database sources be easily changed for test cases? The same test case may have to be executed for different environments, example, dev, UAT, and production.
Yeah, we actually support that as well. Yes, that's actually something that has come up with a few of our clients. And one of our clients actually uses our application. They define it in one pipeline and they use it in 7 pipelines. One of our case studies. So yes, that is something that is supported. And we are bringing more enhancements to that in upcoming releases as well. So it's easier for you to do exactly what you said, define it in one environment and deploy it in multiple. So yes.
Yeah. Another one, what Spark engines are supported?
I am not sure about this one. Is it the underlying technology that you're working with? Spark engines, like you mean Livy, Databricks, or Yarn, I believe. So in that case, we have this as our support. Not sure if there's anything specific over there.
Okay, thanks.
I mean,
thanks
feel free to get in touch with us and have some specifics if that's needed.
Yeah, as saying that, yes, we do have an demo that we can give individually to you or your teams to address any of those challenges, and also do a kind of a POC for any of the use case that you would be interested in as well. With that, thanks everyone for joining us today. This comes to end of the webinar, and we'll catch up later. Thank you so much, everyone.
Thank you, everyone.
Thank you.